We've got the integral from 0 to pi of sine squared x dx. And because we're dealing with a sine squared, this is something that we don't easily know how to integrate, we must use a double angle formula. And for sine, the formula comes with a negative, whereas if this was a cosine squared, we'd be using a positive. So what we can do is rewrite this as the integral from 0 to pi of 1 minus, this is where that negative comes in, cosine 2x all over 2 dx. And the first thing I'll do is I'll kick this 2 out in front, and I'll rewrite it as a 1/2 times the integral from 0 up to pi, 1 minus cosine 2x dx. And because we've effectively stepped down this exponent into a 2 times the angle, the double angle, we can now effectively integrate it. So what we'll do first is we'll say 1/2 times the integral of 1 with respect to x is x, minus, and the integral of cosine 2x with respect to x is sine 2x over 2, and we'll evaluate this from 0 up to pi. And there's two ways you can go about doing this. You can either leave it as is and evaluate, or you can rewrite sine of 2x as 2 sine x cosine x. But in this case, I think that's just a little bit too much work. You don't need to do that for this one. And so what we can do is we can say 1/2 times, starting off with x as pi, we'll write pi minus sine of 2 pi over 2 minus, in parentheses, 0 minus sine of 0, because 2 times 0 is 0, over 2. Of course, sine at 2 pi, that's a full circle around the unit circle, and the y value at that point is 0, so that becomes 0. And the same thing at 0, it's actually the same point on the unit circle as 2 pi, so that is 0. So what this really is pi minus 0 minus 0 minus 0, which is just pi, and it's all times 1/2, so the answer is pi over 2. If you have any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.